So the basics for subnetting is it's based off of 8 bits. So the max value you will get with a single bit in each one of these is 255. How to count in binary is each column. If there is a 1 here, you count for this column, you add 1. If you need to go to, this is probably going to be too quick. So let's say we want to count to 3 in binary. It would be 1. These would all be zeros. So that's 1. We want to count to 2. Put a 1 here and a 0 here. You get 2. That's essentially the basics of it, all the way up. From 3, just like that. The reason it's important to just know is that's the way computers read those numbers. You'll see those numbers in the subnet mask. So, a subnet mask of 255, 255, 255.0 will have all 1s filled here, and each 1, and all 0s here. Is that right? One more. So what happens in subnetting is what you end up doing is you're borrowing bit values. So 1, 1, 1. So this is your network side, and this is your host side. Your subnet mask dictates where your network is and where your hosts begin. So in a slash, this is what we call a slash 24 because 8, 16, 24. If you want to borrow to make your host side bigger, you borrow a 1 and you add a 0. And what that does is changes this to 254. Because if we count from here, we're just minusing 1. Well, it's not really minus 1, but you have, I think it's 7 to the, no, it's 2 to the 7th power. You can pull out a calculator if you want to check my math on that one. Should equal 254. Which is 2 times 2 times 2 times 2 times 2 times 2 times 2. Ready?
2 to the 7?
No, what is that?
128.
128? Sorry, still impromptu.
You're looking for 256?
254.
54.
Maybe it's... Sorry, I would have brushed up on this before. So I know if you do this, if you add up all these, that is going to be 254. I'm just trying to think if it's... I think you do it the other way. Yeah, it would be the other way. So 2 to the 9th will give you 510. Or 512.
2 to the 9? 512.
Yeah. That was the other way. But what that does for your host side is whenever you borrow a bit value, you double your hosts. In a slash 24, you have 255 addresses. The first 2, I'm sorry, the first, I'm sorry, not the first 2. The first and last of an IP address range or a network range are not usable. I'll get into that in a second. But it's the first is the network ID, and what that does is it signifies this is where your network is. And the last is the broadcast. it should start to come together in a second. Let's do this. So a private IP range of 192.168, and I'll use what pretty much all the standard is for like everyone's home network. 1.0/24. In this network, you can call this your the subnet is 255.255.255.0. That's your /24. 0 is the first, and 255 is the last. So you have 0 as the network ID. And all that does is just, again, it signifies this is where the first usable, it's first unusable, but it's the first IP address in this range. And then the last is 255, broadcast. But you get a total amount of IPs of 254. So the usable range for machines or hosts is 1 through 254. That's just as /24. So let's see. If we want to double this, actually, do you want to subnet or supernet, which means make the host smaller? We can go forward or backwards.
Surprises. Surprises.
Okay. We can, you know what, I'll start with going backwards, so subnetting. So this is probably where it is most useful. If we borrow 1 from the left, so back up here, if these were all 1s, we borrow from the 1 column, we get a 254. Now, I did this specifically like that with 1. What you end up having is a 0 and a 1 network. You doubled your networks. So now you have .0.0 as your network ID, and the last usable is 1.255. And 1.255 is the broadcast for /23. Well, we'll do that. So again, when you borrow bits from the left, it doubles your range of hosts, and what it does is it doubles. So like every 255 addresses, it's doubled. At least, well, from a /24 to a 23. And then you double it from a /23 to a 22 with, in this network, there are 510 usable 510 usable, because the first and last are not usable.
Okay. So if you have like a wide range network, you know, you can have multiple. This is standard, this is the class C,
So class full
class full.
is literally just the first number. So if you have a class A, that's a 10. It's from, God, you tested me on that one. 0 to 126, I believe. So class full is literally just based off this first number.
The first after. Okay.
Yeah. A class B is 128, I think,
Class B.
to 191. And then class C is 192 to 222? No. I know there's the range of 223, which is that's for sub or multicast DNS. But let's see how I can actually try to. Do you have any questions real quick? So like interject at any point, because I know this is not going to make sense to a lot of people.
Are you going to go over IPv6?
I'm not going to go over IPv6. I do not know hex that well. I know binary, not hex. Here. So we can do it in the other direction. If you let's go 192 again with 168. 1.0 slash. Let's do slash 25. So now we're going to be borrowing from the fourth octet. We're going to be borrowing a 1. Well, it's 0, oh, we're going to put another 1 there. So what you actually end up having is, if this was your period, this first 1 column, you move it all over, and you have now another column. So you just went from, if I'm not mistaken, I don't know if that's the right way to say it. Hold up on that. Essentially, in the host area, you only have 7 columns. And that will equal 128. All of that together is going to be from here. So, really 127. Because the last bit value to go from 1 to 128 is 1. So everything from here over is 1 underneath whatever column this is. So what that's actually going to do for us is have a range of 0 to 127. And then the next network after this is 1.128/25. And that's taking your host and going smaller. But you're essentially making more networks, because now you just took a normal /24 and split it in half.
So that's what's going to be broadcasting.
The broadcast IP for this network is 127.
Right.
The network ID is 0. The network ID for this /25, the network ID is 128, and its broadcast is 255. It's the binary part that is confusing.
Yeah.
I mean, that's all routing over the wire, so.
Yeah. This is just a way for us humans to
Yeah.
understand it. Because computers just see this. That is purely it. We,
Right.
as humans, will use Cedar to make that easier to read off than 255.255.128, which is one of these guys. Because if you do /25 all the way across, it'll look like this. And that's a /25. If I'm not mistaken. And you can keep doing that all the way down. Honestly, if I were a little bit more prepared, I would pull out the Subnet cheat sheet.
Yeah.
And you can do, like, I would ask you for a /28. Like, how many networks can you cut a /24 into for a /28? Like, that's pretty good. I think it's not, it would be like 0 to 32 or 31 for the first one, 32 to 64. Sorry, 31 to 60. 0 to 31, 32 to 63, 64 to 90, something.
So you have to kind of like pre-plan it when you're setting up DHCP scope, right?
Honestly, no. For the most
Yeah.
part, you can just use a /24. You
Okay.
have to,
But
if
if
you're
it's
setting up
VLAN,
for a VLAN,
yeah, you would have to set up a different IP or...
that's just tagging.
Okay.
VLANing is just for taking one single cable
Mhm.
and having multiple
Splitting
networks
that.
on it.
Okay.
So if you have a well, this is kind of separate from subnetting.
Yeah,
But you can have 5 networks on this one string of cable. And if your port 1 on the firewall or whatever, it has 5, you can have
Split 'em.
split this switch down here into 5 different networks. As a quick example.
yeah.
But the thing with tagging, I know this, again, it's a little off topic, but
Yeah.
one of them is going to be default. One is the default, and then there's 4 other VLANs. And those are the ones that are tagged.
Gotcha.
So, anyone want to do some subnetting? No takers? Okay. Here, actually, can anyone count to 192 on here? Well,
No?
it's just counting.
Um,
Count binary to 192.
Zero.
You just, I don't have a calculator, I'm not good at this, but
I don't have my phone with me, so.
I don't have my phone on me. I mean, I
I'll
can
look
do
at
You wanna use my
my,
calculator?
I have my desk.
I'm not really good at math, so. Yeah. There you go.
So you add from the left.
Yep. You can also
If
try.
you add from the left, then that's the only possible way to do 1, 0, 0, and then 1.
Yep.
Well, it's a bigger oct. You're trying to get the bigger binary, right? So
Pick a random number between 0 and 255.
like if you were to do
Any
255,
number.
like if you did 255, you have to start on the left, right?
Do
Yeah, you wouldn't want to count from the right.
212. 212.
Still start right there. Yep.
Yeah.
So with that, we're at
I mean,
1 there.
I'm doing it by hand, so
28.
192.
64.
I can't do 32. That would come out to 4, 11.
Yeah, 214, right?
Yeah, 214.
Yeah.
What number did you say?
212.
212.
So
you can do
so
16
if
and
I'm 2
2
off of that.
Yeah, we'd skip 32.
0.
I would skip.
yeah,
I would
skip
skip
32.
32.
Then 16, and then 4.
Yeah.
And 4. 0.
So skip.
Sorry, I'm doing that really quick.
Let's skip 8.
Skip 8.
I just need to skip 2.
We're gonna do the math, right? So
Yeah.
I just need to minus 2. I would imagine.
these
it's
computers
that.
are faster than we are.
Sorry.
Wouldn't that be 118?
I'm just minusing 2 from that, so I would imagine it's that. I just did that very quickly.
Yeah, you'd skip the 8.
Yeah, skip the 8. Because that would be 218.
You'd be, yeah, skip the 8. It'd be 16.
So it's not 32.
No, yeah, 16
Yeah, 16
plus 8.
plus 8.
No, I mean, no, skip 8.
Plus
Sorry.
4.
Plus 4. That's it.
Yeah.
That gives you 212. I had to pull the calculator out for that, so.
Yeah.
Yep, 10, 11. Yeah, there you go.
Yeah.
Sorry.
So it'd be
So
1, 0,
16,
0,
0,
1, 0, 0.
1, 0, 0. Anyone else want to try?
Man, this is like first year in computer classes.
Yeah.
Years ago.
I haven't actually had it in a long time. It's been like 8 years. That's why we don't do it that way. We just look at this and just know, you know the basics, but once, this is what a computer sees, like all we need to know is these numbers.
We're about to get dumber, man, because I think some of these systems that are coming out, they can help us plan. They'll have calculators built in.
I mean, there's a Subnet cheat sheet online with a quick Google search away.
But like I think about the public clouds, like AWS, GCP, or whatever, you're setting up like a network infrastructure. You just tell it how many instances of any compute you want and all that. It just comes up with a virtual network on its own, right? So,
Yeah.
yeah.
Let's see. So throw a different up here. Let's go even further back. Do you know what the network ID for this is? Slash 16 is, if we have a slash 16, that is going to be 255.0.0. So for 16, 8 bits here and 8 bits here. And then this is where your network begins. So this is already the network ID. The last usable in this range of a slash 16 is going to be all the way, here, let me just write it this way. All the way up there. One thing I do like to tell people though is when you're actually subnetting and you do subnet between like a slash 24 to a slash 23, and now you have a 192.168.0 that ends at 0.0 and you've doubled, so since you have 2 slash 24s, you have the next number over in the third octet, 1, all the way up to 255. In between that, you can use, it's a usable range, 192.168.0.255. And then 192.168.1.0 becomes a usable IP. So those numbers in between, they're essentially just linked together. They're now one big network. So like, just to say that again, so if like you're counting up from 192.168.0, 0.250, 251, 252, 253, 254, 255, the next number after that is 1.0. It changes that second octet, or the third octet, and it goes into the next one.
What's it called? The subnet?
The subnet cheat sheet. So what that's going to do is just give you, it's a visual representation of all the networks in each, so the network IDs in each subnet that you can actually have. Because you cannot make for a slash 16 this a network ID because for this it actually has to be that 1.0 10.1.1.0 would fall within 10.0 or 10.1.0. To better explain that, 192.168.1.0 cannot be a /23 network IP because it falls within a /23 of 0.0.
So /16.
/16
How many subnets?
Well, it's just one subnet. But
Just one subnet then.
Just one
Yeah.
subnet.
Well, how many networks remain? Oh God.
You need the fish sheet.
Yeah, for that, that's a huge number. It's also a huge, like a giant number for how many network or hosts you have in here.
Mhm.
That was
Yeah. I can't remember that number.
for /16. You have 65,536 addresses minus 2. 65,534 usable. And if you wanted to hop back over to /24, when you have 256, if you went forward and borrowed from the hosts and went to 25, you get 126 usable, 128 total.
Pretty good sized network for that.
Guess I'd say VPNs would have been a lot easier.
Especially impromptu.
Yeah. That's true.
That makes sense.
I definitely recommend going out and fiddling with a calculator.
Yeah.
There's a subnet calculator. It's one of the first ones on Google. It's a blue page whenever you load it. Mess around with it. Also ignore classical. It's almost useless. It's again, just deciding the first number.
The first output.
Yeah.
It's always a-
It actually goes up to class D, all the way up to 254, 255. No, 254.
and no refresher.
I don't even think you can use the last like 30,000 IPs after like 224.
Why?
They're provisioned. Who was it? IANA. The company that dictates or
Oh,
that
the
mandated
IP.
all of the internet back in the 80s.
Yep.
They decided that.
IEEE, right?
Yeah,
Yeah.
IEEE.
IEEEs.
Yeah.
Unfortunately,
Yep.
there's a huge waste of IPv4 addresses. Like,
Yeah.
what is? Can't use the entire block of 127. That's for rerouting back to your own machine. So that's
Are they
a waste
even
of
ready
like.
for V6 yet? For IPv6? Are they even ready for the,
ISPs are using it.
yeah, so not so much commercial
You will not. It will never be. I don't think it'll ever become.
for internal?
I'm
Yeah.
probably going to bite me the ass on that one. It might not ever become internal
Mhm.
unless we. I doubt it. But you'll probably never see IPv6
Oh,
internally,
partner with
besides the
it.
servers and
Yeah.
whatnot.
Yeah, like here.
It's just the volume.
Yeah. Also, we're now
Control.
like 30, 40 years into IPv4, and every device in the world is using it pretty much.
Yeah.
So,
Did they say they ran out of IPv4?
public IP addresses, yes.
Yes.
That's what I was complaining about with IAN or whatever. If you look up the classful routing, the last like class D you can't use.
Any
If I'm
particular
not
reason?
mistaken. Just
They decided
that.
funny.
No, they decided that.
Then
Look up. Do me a favor. Look up classful. Classful ranges.
It is my fault.
Classful
Yeah.
ranges. Network ranges.
they control that.
And it'll be from like class A will be like, if I'm not mistaken, 0, A, B, C, D.
So A is
126.
127.
We're skipping over 127. It's like 131 or 128.
128, 191.
Yeah, 191. And you
And
get 192.
192, 223.
Yep.
And then
And Can you go-
224, 239.
Yeah. What was it?
224, 239.
224, I can tell you right now, is used for multicast DNS internally. And
239.
Class C is enough.
yeah, so what's after 239? That's 240. That's E.
240, 255.
Experiment.
What is that E?
Mhm.
E, yeah.
Yeah. Does it say what it's used for?
Mm-mm.
Not yet. Keeping that to themselves.
But yeah, no. So this is classful, and again, it's only that first number, which is
Yeah.
almost useless. It would matter if you're trying to buy like a block of public IPs and you wanted to, like, okay, well, I want a class B over here that's a 191,
Mhm.
but class C, that doesn't matter for like 192 is a private IP address, 193 is not.
Right.
Well, I should say, take that back. 193, 192.168
Yes.
dot 0 slash
Better.
16 is an internal. 192.168, oh sorry, 167, or any number around that is a public IP. Because of subnetting. Let me see if I'll write it up here just because. So I do 100% know my internal IPs. So these are your private IP ranges. Uh, 12. And then you have 192, 168, which we all know. If I'm not mistaken. So for /8, that means you can use anything in 10. Here you can use 16 to technically 31. So you can use 172.17, you can use 172.30, all the way to 31 in that one. But after that, 172.32 is a public because it exists outside of that /12.
Okay.
And you'll see it in some of our clients' networks where someone
I have 172s.
uses something like 191,
Yeah.
168. And I'm specifically calling out Caliente.
Yeah.
That's a public IP address and you can use it internally.
Yeah.
Because some of that equipment might actually exist
Outside.
in a public space. So routers will let you do it.
Interesting.
Yeah.
Interesting.
Okay.
This is all helpful.
Common one. Yeah, we know 192 is most common for our clients.
Yeah. That one you'll see almost everywhere.
Yeah.
The other one is 254.0. 192.168.254.
And then there are some 10 dots that I've seen from clients.
I like using the 10 network.
Mm-hmm.
A lot of people do.
Yeah.
Why?
It's 10. It's easier to remember than 192, 168.
It's
And
very
you also,
common.
if you want to, the other good reason to use it is because now you have 2 more octets to make numbers off of. So like if you want to, so like from a standpoint of, let's say we have 10 locations.
Yeah.
Well, we can use 10.1, we can use 10.2, so on and so forth.
Yeah.
And say that's Tampa, Clearwater,
St. Pete.
St. Pete.
Very beautiful.
Yeah.
It's easy for identification.
And so so this is actually how Plato is set up.
Mm-hmm.
The third octet is then for the networks inside of this location. So if you could break this up with /24s to just make it easy. So let's say that was Tampa. So 10.1.0 to, I'll just keep it simple, 1.0/23. You can make this octet, this third octet, 0 to 1, student networks. And you can keep that across the board for other locations. So if you ever look at, say, 10.5, and it's 10.5.1, well, that's a student.
Or to have a Wi-Fi, you want to separate.
That
right?
too. Usually I make it completely
yes,
separate.
Wi-Fi, yeah.
Yeah, if it's a public Wi-Fi, I usually almost always do something in the 172.
It's up to an hour. Alright.
So this is subnetting.
Yeah,
It's not very much of networking yet.
no.
Networking happens all with the, well, mostly happens in the router.
Oh, that's helpful.
Any questions?
Information. No,
Nothing at all?
none.
Sure,
Someone can do this?
We're gonna have to have a refresher tonight, but it's,
Yeah.
makes
Yeah.
sense.
Basic.
Again, the one thing I would take away from this, out of all of it, is to remember that whenever you go, when you're subnetting and you're borrowing from the left of these bit values, so you're borrowing from the third octet, you're doubling it. Or if you're going to the right, you're dividing by 2. So
Okay.
510 or 512 divided by 2, what do you get?
You said 512?
5,
Yeah.
hold on, 256, I'm sorry, 256, I fucking took it off.
512.
I did a slash, there was a slash 23 there, I was going back to,
Oh, okay.
sorry, my bad. So 512 is for a slash 23, so to go back to a slash 24, it would be 256, or it would be back to a network of 256. And if you did it to slash 25, that's when you get 0 to 127. And then 128 is the next network, up to 256. Right? I don't know if I'll know. No, I don't think I am. No, I'm not. I do like to think, or write it out like this, for a slash 23. And the next one after that will be, whoops, 2 to 3. And the next one after that, 4 to 5.
And then 6, 7.
I'm sorry, that was right. If we do that, now we get want to take a guess if we do it again? Oh, it's just 0 to 1, and you double it. What do you think the next ending is going to be? It's doubling it. We just doubled 0 to 1, so now we have 0, 1, 2, and 3. That was 3. There. And that has 1,024 addresses in it.
Addresses.
1,026 minus 2.
Wow.
Wait, or did I? My math was off.
Yeah.
Calculate.
512 times 2 is 1,024. No, 1022. My bad. 1,024 total addresses. 1,022 usable.
Oh, what time is it? One.
Anyone want to try it again? This will be the last one. 21.
Give me one.
0 through 7.
I think 5.
Gotcha.
If you thought 8, you weren't counting 0. That's why. 0, 1, 2, 3, 4, 5, 6, 7, 8.
Okay.
Well, 7 is 8. Is the 8th network.
Yeah. 0 is technically the first one.
Yeah. You count the zeros.
Yep.
Yeah.
Okay.
Now, you can throw that into or you can look up the cheat sheet to see how many times that, like a /21, that's going to be essentially how many networks are here is 8. So you have 0, 1, 2, 3, 4, 5, 6, 7. And each one of those is arranged in the 4th octet, 0 to 250. Well, 5, 0 to 255. All the way down.